Hi everyone, welcome back to Data Cadence. My name is Rahul. I work as a senior applied research scientist, and in this video we are going to talk about a very powerful technique for combining multiple search outputs, particularly when it comes to hybrid search systems like those used in RAG. So for this particular video, the prerequisite is that you understand the basic level architecture of RAG, or what does a basic RAG pipeline look like. If you do not, definitely consider looking at the generative AI playlist that we have on this channel. And I think the last video in which we talked about why re-ranking is essential for RAG, there I talked in a lot of detail about the basic RAG architecture, what is a bi-encoder, what is a cross-encoder, what is re-ranking, how is it done. So definitely refer to that if you are new to this, because that will serve as the foundation for this particular video. And in that one also we had talked about that we will be talking about reciprocal rank fusion in one of the future videos, and here we are. So like every other video, we will start with a lot of the basics. We'll try to understand the why, what and how of RRF and why is it essential. So let's talk about the first question, that is, why do we need RRF or reciprocal rank fusion? So in modern information retrieval and search systems, there are multiple ways to basically search for the relevant information. And two of the most common approaches out there are the keyword based search. So you have things like BM25, which is essentially an extension on top of TF-IDF, if you have heard of that. And the second way to do is the vector-based search that you do via the embeddings that we have been seeing for the last 2 to 3 years. They have become immensely popular. Now, until recently, people used to do vector-based search for all of the things and for all of the use cases. But then people realized that vector search is good, but it might not be the silver bullet that you can use for everything. And that's where I think keyword based search started to come up, and then both have their own pros and cons, of course. So things like keyword based search and BM25 are great for exact keyword matches, but it struggles with understanding the semantic meaning of your queries, whereas vector search on the other hand excels at capturing the semantic meaning but might miss out on the exact term matching. So consider an example where you want to build a RAG system for one of the organizations on their custom proprietary data, and that data has a lot of the keywords or say acronyms and all of that, right? So in such a scenario, understanding both the semantic meaning and doing the exact keyword match might be very important, and that's where you got to use the best of both the worlds, right? So the question comes is, how do you combine to get the best of both the worlds? And that is where RRF comes in, or reciprocal rank fusion comes in. And mind you, we have discussed about two of the most common approaches, that is keyword based search and vector based search. But RRF as a concept is very generic and it can be extended beyond these two approaches. So you could include other things like graph based search and all of the other search based systems that you might have. And RRF can give you a very good combination of all of those. So let's talk a bit more in detail about what exactly is RRF. So like we mentioned, RRF is a simple yet effective method to merge the outputs of multiple rankers. And these rankers could be semantic based, this could be a lexical or keyword based, this could be a graph based search, and so on. Now how you do that is, for each of the document in your search output, you basically calculate its reciprocal rank. And this reciprocal rank is given as 1 over k plus r, where r is the rank of the document in the search results, and k is basically a small constant that smoothens the effect of low ranked results. And k is usually taken to be 60. Now you might ask why 60? So 60 is not a rigid rule, it's a rule of thumb after a lot of empirical results, and it was seen that across different domains and different retrieval mechanisms, 60 usually worked well, but it doesn't have to be 60. You can play around with different values and see what works best for you. So essentially how you do is you sum up the reciprocal ranks across different search methods for each of your documents. We'll see an example and this will become more clear. And the final score for each document is the sum of its reciprocal ranks from all the systems, and then finally you sort the results based on these combined scores. Now we talk about why is it important. So like we mentioned that it allows to create a single ranked list by balancing the precision of a keyword search along with the semantic understanding of the vector search, and essentially that gives us best of both the worlds, and which makes the search more robust and effective. And mind you that an effective retrieval pipeline is very much essential to make your RAG system work, because if the retrieval is poor, then you will retrieve poor context and give it to the LLM, and the LLM will not be able to generate appropriate or relevant responses corresponding to the user query. So definitely it is very important. And finally, let's talk about one of the examples to better understand how is RRF calculated. So let's look at a very simple example. Say you have three documents and let's have two search systems in place. Say you have a keyword search based on BM25 that returns document A, document B and document C along with their respective ranks, say rank 1, rank 2 and rank 3. And you have a vector based search based on embeddings that returns document B at rank 1, document C at rank 2 and document A at rank 3. Now for the document A, okay, excuse me, sorry about that. So yeah, so now for the document A, the rank based on the BM25 would be given as 1 over 1 R plus K. So for the BM25, you can see that A was assigned rank 1. So you have 1 over 1 plus 60. 60 is the constant that we had talked about. So this would come out to be 0.016. Similarly, you calculate the rank for embedding. So in the embedding approach, A was assigned a rank of 3. So that is 1 over 3 plus 60. And that comes out to be 0.014. And then the final score for A would be the summation of these two. And if you would have had another search mechanism, say based on a graph search, so you would have had another rank for the document A, and the final final score is basically the sum of all the reciprocal ranks that you have calculated, and that comes out to be 0.03. Similarly, B was assigned a rank of 2 and when it came to BM25 and a rank of 1 based on the embedding approach. And similarly, you end up with a final score of 0.031 for B. And similarly for C, you end up with 0.029. Now the final ranking order after performing this reciprocal rank fusion is you simply sort in the descending order. So you see that B had the highest score of 0.031, followed by A which was 0.03 and followed by C which was 0.029. And that is how you see that you end up with a really good ranking which considers the best of both worlds, including the best from both keyword search as well as your embedding based search. So like we see, RRF is a very simple concept, but it's very powerful and very effective. And hybrid search is becoming really popular these days because people want to make the retrieval pipeline as robust as possible in order to have a really robust RAG system in place. And to conclude, the key benefits of RRF are that it's pretty simple to implement. So RRF is really easy to understand and compute. It is pretty effective at balancing precision and semantics. So by combining both keyword and vector based search, RRF provides a hybrid system that performs well on a wide variety of queries. And finally, you have improved relevance. So the fused ranking is typically better than relying on a single search method alone, improving the overall retrieval quality in systems like RAG. So I think that's it for this particular video. Hopefully you learned something new, or if you were already aware of RRF, hopefully it gave you a good refresher. If it did, please consider liking this particular video. And if you're new to this particular channel, consider subscribing to this particular channel for more such videos around data science interview prep, generative AI and a lot of the traditional data science topics as well. So thank you so much for sticking around till the end. I will see you in the next video then. Until then, take care and keep learning.